Everything from yesterday's lesson was reviewed from physical science. You guys know that? And we'll start with, we'll just do this. Oopsies. All right, quick 4-minute review. What's that called?
Coefficient.
I don't even know how to spell that. There you go. I think something like that. Okay. What are those called? Thank you. Reactants. What does that tell you?
What phase it's in.
Gas state. Okay. What's the purpose of this?
To
Separate your, if you have more than one what? Reactant or more than one product, okay? What are those called?
reactants and product.
Yes.
Products.
You guys read on this, didn't you?
Yeah, it's on
Okay? Reactants produce
product.
products. Okay? So reactants react, products are produced. Makes sense? Okay? What's this? Tell me.
The liquid.
Liquid state. What does an S tell me?
Solid state.
What does AQ tell me?
It's dissolved in water.
Dissolved in water. It's called aqueous. It just means something has been dissolved in water. This arrow. What is this arrow? Purpose of it?
This goes to that.
Yeah. It's separating your what from your what?
Reactants from your products.
Reactants from your products. Okay? What does the coefficient tell you?
How many of each is it?
So I have two what?
Two sets of two hydrogen. So you have
I have
four
two hydrogen gas molecules.
Yeah.
Do I have two? Does this two go to this as well?
No.
No. That's what the plus sign is there, is to separate the different substances that you have. Okay. I know I'm drawing all over this, but what is that?
Subscript.
Called a subscript. What does it tell you?
How many of each atom you have?
How many of each atom you have in a particular compound or molecule. Make sense? Okay, so if I have a coefficient and a subscript, what this tells me is I have two H2 molecules and there are two hydrogen in each one, so you do it like you would normally do simple math. Okay, so let me give you an example. Let's say I've got four there. So the 4 tells me I have 4 of this whole thing, correct? What does this 3 tell me?
You have 3 of those.
I have 3 NH4s in one molecule, or in this case, forming a unit. Okay? So let's try to figure out how many hydrogens. I'll start with nitrogens. How many nitrogens do I have? Raise your hand if you think you know. Quinlan? 12. 3 in 1. 4 of them. 4 times 3 is 12. Okay? Hydrogen, raise your hand. 1. Come on. Come on. Come on, Tanner. Tough one.
48.
Yeah. More than I thought there was going to be. Okay? 3 times 4 is 12. So there are 12 hydrogens in one of these formula units, but there are 4 formula units. So 12 times 4, 48. Okay, how many phosphoruses, Tyler? That's pretty simple, right? There's only one phosphorus in one molecule, or one formula unit, so if I have 4 of them, got 4. And Morgan, oxygen.
16.
16. Get it? Find a little 5-minute, 4-minute crash course. It's good now? Okay. Now I'm not going to go over that worksheet because you guys didn't do quite what I wanted anyway. So I'm not.
Erase marks.
So yeah. Well, shoot, you did all that work, but then you didn't.
Yeah, I
erase
was
it
like,
all.
no, you're supposed to do the total atoms. I was like, okay.
Did it say total in there?
Must just find how many atoms.
It said are in each of the following, and I thought that meant in each of the following these, but everyone said it was each of the following like problem.
Should have said element
Maybe it wasn't super clear.
of each.
Okay. So today is really the combination of all the stuff we've done for a while. So, you ready?
No.
First of all, why must the chemical equation be balanced?
Because you cannot create or destroy.
What law is that?
A law of conservation.
First law of thermodynamics, or the law of conservation, or the law of you're not God?
Or that.
All right, last time I checked, can you create matter, Gage?
No.
Can you destroy matter?
No.
No. Yeah. Yeah. Yes. Okay.
Will.
So, here's what we're going to do. We are going to do quite a few things today. We're going to start by doing balancing chemical equations, the steps for balancing chemical equations, and then we're going to do word equations. Ready? Okay. We're going to start with a couple, well, one easy one, and then we'll get to some more difficult ones. Cool? Okay, so here are, there's about 4 steps that you can do to check to make sure you're balancing the chemical equation correctly. So first and foremost, I'm just going to give you the formula for the equations. So NO, O2 goes to produce NO2. So you need to be following along here with me. Now I should probably have the phases that these are in, but for the sake of what I'm about to show you, I'm not too worried about that. Okay? Normally, you will have to write those formulas from a word equation. So, wait, Mr. Kramer, you mean when we spend all that time writing formulas and naming formulas, we actually still need to remember that? Yes. Okay? Now it says, write formulas for all reactions and products. That would, again, be assuming you were given a word equation that you had to do that for. Okay? Make sure that all the formulas are correct. Why would you want all the formulas correct? Yeah, you don't want to create or destroy matter. Also, can you balance the chemical equation? Could you make it have the same amount on both sides if you messed up one of the equations? No. Or one of the formulas? No, you couldn't. So, make sure you have the formulas correctly. If you're going to speed through anything, speed through the balancing. Okay? These questions you're going to have on your test are going to be 10-point questions. And then you get a point for every right formula that you have, every right phase, or phase that you correctly put in, every balanced thing you got correct. Okay? It's a lot. Okay? Then it says, once you have written your formulas correctly, what?
Do not change them.
Here's why I put that up there. You don't want to go, I got 3 oxygens here, so I'm going to go like this. No!
Nitrite.
It's a completely different thing. You can't do that. Okay? Once you have written the formulas correctly, no touchy. Capiche?
Good.
Hands off. Okay. Step 1. Done. Okay, step 2, you should remember this from physical science. Make a T-chart. Yeah? You remember that? Yeah?
Something like that.
Yeah? Make a little T. Yeah. I'm gonna go left and right. You could do reactants and products. I don't care how you do it. Okay? And then what we're gonna do is we're gonna take the atoms that I have in this equation. And in this equation I only have two different atoms. What are they?
Nitrogen, oxygen.
I'll write them over on the left-hand side. Okay, and then we're going to count. The purpose of yesterday's lesson was so that we could do this. We have to be able to count the atoms so that we can balance them correctly. Okay? So, Gage, real hard one here. How many nitrogens do you have on the reactant side? One. Put it there. So I have L and R. That just means left of the arrow, right of the arrow. Okay, you could put R and P, reactants and products. I don't care what you do. Do what works for you. Okay? Morgan, how many oxygens do I have on the left side of the arrow or the reactant side? Yep, 3. Yep, so I'm talking total oxygens. Okay, so now we're talking about amount of atoms on a side. So you might have some elements that appear in multiple things on a certain particular side. Does that make sense? Okay? And then looking at the product side, I have 1 nitrogen as well, and how many oxygens? It appears that we have played God, huh? What did we do? We destroyed an oxygen. Oh, but wait!
There's more.
No! Do not do that! Okay, this is where coefficients come into play. Okay? Once we've identified that we have not balanced them, we can move on to step 3. Adjust coefficients until there are equal number of atoms on both sides of the arrow. Okay? Now this one's a little bit goofy, because normally in a situation like this, I would say least common multiple. Okay? But since oxygen appears in 2 things over here, it's not the case. Okay? So I'm just going to start by going and putting a 2 in front of this. Now, just wait, let me explain. Okay? When you put a coefficient in front of something, that's going to change how many atoms you have, isn't it? Okay? When you do that, go back and fix. So now how many nitrogens do I have on the product side?
2.
Okay? How many oxygens do I have on the product side?
4.
Okay? You're probably thinking, you didn't balance a thing. Well, true. But it's like a chess match. I feel like there's a few of you that might be pretty good at this. You kind of got to look ahead. Okay? Well, let's see now if I can balance everything by doing a few things over here. Okay? Anybody see what needs to be done? What's so funny?
You need a 2 in front of the. No!
Because what that does is gives me 2 nitrogens on the left side. And now how many, if you have to recount everything, do it. I got 2 and 2. 4, 4. 4. Look it! We're no longer God. We let God be God. And we just did.
We were laughing because I told him we should play chess at lunch because we used to do that. In junior high, all year we played like a chess game at lunch. Instead of home.
Okay.
And
Last step here says, this one you probably won't do much. It may come in handy. Okay, so check to make sure coefficients are whole numbers. You're probably wondering, what in the world? You will never probably do this, but you could technically balance it by going like this. Wouldn't that balance it? Technically, okay? But what I'm trying to say is we're not going to use fractions, okay? So if you come across something like this, multiply everything by a number that would get rid of your fraction. So what would that be? 2. That becomes a 1. That becomes a 2. I don't think you have to worry about that. Just showing you guys that that could be something that you'll run into at a later time.
That's
Secondly,
splitting that in half.
what was that?
That's splitting that reactance in half.
Well, actually, what this means when we get to a little bit higher level, this tells me how many moles of atoms I have, or moles of compounds I have, and a mole is actually 6.022 times 10 to the 23rd. So if you had half a mole, it's just an amount. Okay, so when I say 2 of these, I really mean 2 moles of those. But I haven't given you the mole yet, if that makes sense. Okay? Second thing, believe it or not, you could balance this at multiple points. If I had this 4, 2, and 4, would that be balanced? What about 8, 4, and 8? Would that still be balanced? Yes. Okay? So it's possible that you might be trying to balance these guys and eventually you miss the first balance point and then hit it at later. If you do that, you need to always look to see can I reduce? So for example, if you didn't get it 2, 1, 2, but you somehow got it 8, 4, 8, if you can reduce. What does that reduce down to?
2, 1, 2.
2, 1, 2. Okay? Now you most of the time will probably get it the first time, but just in case. Okay? Let's crank it up a notch. How about it? Okay, here's a few hints, because I gave you a relatively easy one. Okay? This is kind of common sense, but do one at a time. Don't try to go too far advanced. Like if you want to think a couple steps ahead, that's fine. But when you're balancing, still do one at a time. Okay? And then it says, number 2, start with the element that, if combined, appears in only one thing per side. What I mean by that is, this one we just did. Which one would you start with? Which one would you balance first? You would try to balance nitrogen first. However, nitrogen's already balanced, so there are some other subtleties. But what this rule is saying is, it's more difficult to try to balance the things where elements appear in more than one compound per side. Okay, it's just more difficult to balance those guys. So, balance them last, because sometimes you can balance the other ones and they'll balance themselves. Does that make sense? Okay? Wait, we're going to add polyatomic ions in here? Yes. Okay? It says balance polyatomic ions that are unchanged in a reaction as single units. Here's what I mean by this. If you have phosphate on the reactant side with something, and it stays as phosphate on the product side, then when you make your T-chart, you do not have to break it down into phosphorus and oxygen. You can leave it as phosphate.
And if it's there and not.
If it's phosphate here and is not phosphate on the other side, you do have to break it down into phosphorus and oxygen. Okay? It's just a simpler way. If it stays the same on both sides, it's easier just to treat it as one whole unit. Okay? Last rule. It says balance hydrogen and oxygen atoms last, essentially. And the reason why it says to do those last is because those are the 2 main culprits of disobeying that rule. What do I mean?
There's multiple.
Hydrogen and oxygen are the most likely guys to be in more than one compound on a side. Make sense? Okay, alright. You guys look tired. Maybe I should just let you do the next problem. Here are just about 3 vocab words that I will talk about relatively quickly. Okay? We'll talk much more about reversible reactions when we get into equilibrium. That's a long ways away, but I just wanted to give it to you. Okay? A reversible reaction is one that can go forward and backwards. In fact, almost all reactions do that. Joke's on you guys. Okay? Precipitate. Okay. We'll talk about that at a much later date. Okay? But be able to answer a true or false or multiple choice question on that. Okay? Precipitate. What a precipitate is when you have something dissolved in solution and some solid crashes out of solution. We would call that a precipitate. Okay? For example, if you were to dissolve salt in water and then evaporate a little bit of the water, you would see some salt sitting on the bottom. That would be a precipitate because it came out of solution. Okay? And lastly, catalyst you probably talked about in another science class here at the school. I'm hoping. Biology? Talk about catalysts? Okay. We'll talk about more about catalysts in a second semester, but it's really something that changes the rate. What is the rate? What's rate mean?
Speed.
Speed. How fast? So a catalyst speeds up a reaction without what? Getting rate change. They don't get changed. So a catalyst gets put into a reaction to make the reaction faster, even though it doesn't get consumed or used in any way. Used up, I mean. It doesn't get changed. Okay? This is a fun guy. Let's start with this one.
Fun guy.
Ready? Word equation. We need to write the equation first, then balance the equation. Ready? Slowly do this. First thing, it says solid iron. Huh. How would I do that? Is iron diatomic? Okay. Do you remember that time, all those times where I hammered into you diatomic elements and how important they were going to be? Okay. This is what I was talking about. Because if you have an element by itself, you need to check if it's diatomic. Because if you do not show that it's diatomic, and it is that going to throw everything off?
Yes, sir.
Sure is. You'll see that as we progress. Okay? Solid iron, so I have your parentheses solid. You won't adopt if you don't put that. Okay, there's a little and here. What do you think that's telling us?
Plus.
Okay, I got another reactant. Okay, chlorine.
Cl2.
Woo!
Little g.
Why Cl2? It's diatomic. Do you see how that little subtle thing would quite significantly affect your ability to balance this guy? Do I need to refresh the diatomic 7 or 8? Or do you guys remember the diatomic 7-on-7 rule? Start with the atomic number 7, make the shape of a 7. There are 7 of them, and there is one other exception. It is hydrogen. Okay? All right. Then it says react to form. Is that important in any way?
Well, that means your arrow.
That tells me that I am taking a turn towards the products. Okay? Ooh. Iron 3 chloride. So, iron, chlorine, done?
No, powder.
FeCl3. Here is the #1 mistake students make. When they're doing chemical equations, they completely throw out the fact that there is a specific way that you write formulas. AKA the crisscross method if it's ionic, and Greek prefixes if it's covalent. So 3 plus, 1 minus, crisscross down, FeCl3, and what's the phase?
Powder.
What's
Solid.
Makes sense, right? Last time I checked, powder was a solid form, right? Okay? Maybe we should just, glance over it a second time to make sure we did everything right. Now, yes, we did everything right. What would we do next? Make a T-chart. Okay, now I realize you could probably do this one in your head, but there are some guys that you will not be able to. Okay? Rapid fire. Tanner, how many irons do I have on the left side?
1.
Rachel, chlorines.
2.
Marty, right side, iron.
1.
Morgan, right side, chlorine. 3. Now, here is a situation where I am going to suggest least common multiple. And the reason why I'm going to suggest least common multiple is if you look up there, iron and chlorine only appear in one thing on both sides. Make sense? If they appear in more than one thing, least common multiple doesn't always work. You have to think a little bit outside the box. Okay? What is the least common multiple of 2 and 3?
6.
6. So I don't care which one you start with. Let's make one and then both 6. Gage, help me out. Help me get 6 chlorines on the left.
We're going to do 3 and finally 1.
Why not change that to 6?
Just can't do that.
Because CL6 doesn't exist. Okay? Quinlan, can you help me get 6 on the right? Yes.
Thinking about pause.
Yep. This is something that sometimes we can mess up too. You cannot put coefficients in the middle of a compound. Does that make sense? It goes in the front. Okay? So that does affect what then? Yeah, it's going to affect iron and chlorine. So yes, we did temporarily unbalance iron. Not the end of the world though, is it? Okay? Here? Done? I forgot to change that to 6.
Wait, so why don't we have Roman numeral 3?
Because you only need Roman numerals in the name. I mean, that's what that came from. Questions? Now, this one was still an easier one. Next one will be a hard one. Ready for it? I am going to help you with this one as well. This one's not hard to write. It's actually more difficult to balance. Anybody want to start helping me out writing this guy? Not all at once.
C2H6 plus.
Hold on.
Hold on.
What should happen before a plus sign?
The solid.
Oh, the phase. Oh,
the
little
gas.
G. Yeah, little G. Plus O2.
Ooh, IO2.
Because it's diatomic element, little G. Arrow.
Producing, right? That's where that
Yeah.
comes from. Producing.
CO2, little G, plus H2O, cursive out.
That's funny why they make that cursive, isn't it? I don't know why they do that. Okay, so in the previous one we had some ionic compounds, and now this one we've got all covalent. So again, still very important to be able to remember that when you write ionic, you do have to use the crisscross method. Okay? The reason why this one's going to be a little bit more challenging is because of that and that. Left and right. Am I going too fast for you guys? Okay. Tanner. Carbons, left side. Help me out. You Did you do hydrogens as well?
Yep, 6.
And oxygens?
2.
Alright, I'm gonna give myself more room because we're gonna do quite a bit of erasing, I think. Okay, let's see. Benitez, could you help me out on the right side? Carbons? Hydrogen? What'd you say? 2, yep. And oxygens? 3. Who's that? Wow, I put that 3 in a weird. Sorry, guys. I did not realize
She would've freaked out.
Woo! I thought I did that good. Oh, goodness.
That's good that Trinity's not here, she would've freaked out.
Who?
Trinity?
Yeah, that's true. Okay, so there was a few tips and hints there was 4 tips and hints that could help us a little bit here. Stay away from what?
Oxygen, hydrogen.
Okay, so let's do what first?
Carbon.
Okay, let's do it. How do we balance it?
I would just take it on like this. Carbon, there's less carbon on the right side than on the left, less hydrogen on the right side than the left. So we're just gonna have to do, I'd put a 2 in front of the CO2 first, and then a 3 in front of the H2O, then balance out the oxygen.
Okay, so let's put a 2 there, like he said. That'll balance our carbons. Okay, that'll give us, we have to be careful because we gotta go back and recount the oxygens here now. How many oxygens are here?
4.
Plus
1.
5.
Oh.
And then we can balance the hydrogens like he said by putting a 3 here.
Unless.
That'll make this a 6, and then we have to go back and recount the oxygens again. I have
2.
no
4.
4 plus
3
is
7.
uh-oh.
Great. Now I made it even more tricky. But they can just do 14.
What do I do? Because I can't change the CO2 or the H2O without changing and unbalancing my carbons and hydrogens on the reactant side, can I?
Why can't you just put 7 on that one?
Because that would give me 14.
No.
Did you at least count multiple to well before? Oh,
You need to get that 3 to be a 4.
No. What? You want? I could let you guys struggle for a little bit. We don't have a whole lot of time. Okay, so this one's trickier because of these 2 oxygens here. Okay? And everything's balanced except for the oxygens. Okay? Alright. In a situation like this, okay, I could still maintain the carbon and hydrogens being balanced if I doubled these. Let me explain what I mean. If I take and I double these, and I double this, won't that maintain carbons and hydrogens being stable?
Oh.
Let me show you. If I make this a 4, and I make this a 6, I should have doubled everything on the reactant side, correct? So, that means 4, 12, and 14. Yes? Everyone see how I doubled everything? Okay? This would rebalance my carbons and my hydrogens.
I put the 7 there.
So essentially, it was a difficult way of doing least common multiple because we had 2 and 7, right? So I doubled this side to get 14 so that I could change this to get 14. By doing what?
On the 7, running up to.
That one was a thinker. A little bit. Okay? That one was up there in the level of difficulty. You guys will see this here. Okay? Questions? There is one more. We probably won't get to balancing it, but we certainly can get to practice in writing it. The reason why I want to get the practice in writing this is because my guess is that you guys will struggle to write this because you'll forget the rules that we've been talking about for a while. Okay?
A-L.
So man, you guys gotta start memorizing those polyatomic ions real quick.
A-L-N-O-3. A-Q in the parentheses. Plus.
Wrong! Wrong, 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 wrong.
Parentheses
Wrong.
3.
Dang it!
Why?
Because aluminum has 3.
3 plus 1 minus. Is that not what I said you guys would struggle with the whole time? You forget the rules that I've taught you up to this point. It's ionic crisscross method.
Y'all.
Slow down.
No.
I knew it. Thank you, Rachel.
Plus Na2. Pretty sure.
So Na is 1 plus. CO3 is carbonate, and I'm guessing you don't have your polyatomic ions
Minus
memorized.
2.
It's things are starting to heat up now, aren't they?
Na2. I told you. That's about it.
What is the state?
Also, Zacchaeus.
Zacchaeus was a wee little man.
So,
2 form. Okay, what does this tell us?
also Zacchaeus.
What does that tell us?
It's a.
It's a salt.
Oh, it's a
It's
solid.
a solid.
Dang it.
Aluminum carbonate is a solid. So again, Al3 plus
C.
we know what carbonate is CO3 to minus.
Al.
Oh shoot, I need to give myself a little bit more room than that.
Al2
Al2,
CO3
CO3, 3. Holy buckets! We haven't even started balancing yet.
Jesus Christ.
Plus
Na. NO3. Na2. No, yeah, we're good.
you guys. Remember that little day that I said, you know, it's a whole bunch of easy things that just start to build, you know?
Doing the test, I am going to remember the NO3, but I won't remember the charge, so I'm just going to do Lewis structure to find out the charge.
Yeah.
For every single one.
Okay, now I'm not going to go through the balancing, but guys, in this situation, notice how nitrate stays as nitrate and carbonate stays as carbonate. So when you're doing your key charge, you can keep those as polyatomic ions. So how many carbonates do I have?
3.
3, so I will probably need to put a 3 here. Make sense?
6.
Okay, let's just see if we can do it in our head. 3,
Okay,
okay,
6.
I need 2 aluminums, 2, that gives me 6 nitrates,
Which is good, because.
which means I have to put 6 over there, and does that balance our sodiums?
Yes.
Yes. We're done.
Do you have homework?
Yes. In your worksheet packet, you have 5 balancing and you have 5 writing then balancing. Come hang out with me after school if you'd like.
Well, when do you guys do the thing like 4 of them? We like 4 of them, or you think of like all like equal each other?
Oh, has this long?
Yes, Jack.
Isaiah.
Oh, what are you
This.
eating?
This. What are you eating?
I don't know, kid.